Okay, so this is going to be my first effort in trying to do a class recording, so I'll try to break this into as many videos as possible so it's easy to navigate. That way you're not scrolling around with time bars a whole bunch. And I'll try to speak loudly because I think the recording isn't picking up my voice too great, so I'll try to work with that as well. First, I'm going to go over some review from last week. We had an exercise where we were talking about, or where we were exploring different types of modeling efforts. So linear regression models, as well as random forest models, and how those are working, what they do, how to evaluate them to make sure that they're working well, how to treat the data prior to um, making those models, and then doing a comparison to see how well each one performs. And so this was part of the homework assignment, and I'm going to go just a little bit over this. This was the visualization, but I hope nobody had too many problems running. But looking at it, we're going to compare a linear regression model and a random forest. There's many ways that we can change this training and testing split ratio, but remember that training data is what we build the model off of. Testing data is what it's going to be evaluated on. And that's kind of the more important part. We need to make sure that our model is predictive enough to take on new data. I'm going to pick, I'll just do 80/20. And then the error metrics to display. So these are different errors that we could measure: root mean squared error, mean absolute error, and the R squared coefficient. And so if we look at all of these, we can get a good understanding, comparatively speaking, how these two models compare. And so if I run the analysis, right, this was giving us some of our information. And so I'll read through some of this, and that will be our review, and I'll move on to kind of a different presentation and other machine learning methods. So here's our total of records that we used. We used 120 to generate a model. We tested against 30, and we used all 9 predictor variables, and we're looking at, I believe, profit, right? So we're trying to predict profit. These are the two models. First one's linear regression, the other one's random forest. And we can see the comparison between the errors for root mean squared error on test, uh, mean absolute error on the test group, and the R squared coefficients. These are highlighted because these are the test values, which are a little bit more useful in evaluating than the training data. Right, we should have much better performance on the training data. So if you can see here, the R squared on the training data and the R squared on the test, there's a significant drop, right? This is less significant, but it's still a drop. We should expect that. Right, here's how visually you can look at the error. Again, we're trying to get as close to this line as possible. So the further away you get from this line, the worse it gets. That's the R squared work. And then we have these distributions for errors. Again, this is where we want to be. We want to have everybody have 0 error, and the wider we get, more error we have. And then you had a video assignment to upload. But that's the review for today. You can look at this data if you want. There's not really much point in doing so. But if you want to look at it, it's there. This is built off real data, and you can mess around with this as much as you want and just rerun these and kind of compare different models that we do. I know we didn't cover partial least squares or general linear models, but those were just kind of different ones to just so you could play around with and see what's going on. Okay. So I'm going to stop, and then we're going to go to our new topics for the day, which is new machine learning models.